Okay, bridge students, for the third and final video on the Pythagorean theorem and the distance formula, we're going to apply two approaches to finding distance. And one is the distance formula, and we're going to plug numbers in. And the second is a more visual approach where we're going to draw a line segment. We're going to drop a right triangle from the line segment, and we're going to apply the Pythagorean theorem. And I want you to be comfortable with both these approaches. Some people prefer one, other people prefer the other approach. They both amount to the same thing. So either one is good. All right, the problem says find the distance between the points -1, 2, and 3, 5. And the first approach is using the distance formula. And if you're going to be using that approach, the important thing, I think, is to be really particular and careful. Students who succeed at this often do what I'm doing right now. They label this. We'll just call this x1, y1, x2, y2. Once again, you could flip these. If you wanted to call the 3, 5 x1, y1 and the -1, 2 x2, y2, it doesn't really matter. The subscripts just label the points. All right, now we're going to plug in, and choose a little bit thicker line here, and we're going to say d equals, and then we plug in x2 is 3. x1 is -1, so we say, this is a tiny bit tricky, minus -1 squared plus, let's see, y2 is 5 minus 2. Okay, and then we solve what's inside the parentheses, and so 3 minus -1, as you'll recall from our work with integers in the 7th grade, is going to be 4. So this is 4 squared plus 5 minus 2 is 3, so that's 3 squared. Yeah, and 4 times 4, of course, is 16, and 3 times 3 is 9, so this is 16 plus 9, d equals 25. 5. I always want to put units, so in this case it's 5 units. All right. So that's a great approach. You get to use a formula and just plug numbers in. It's very mechanical. It's very satisfying for people who, particularly people who are really precise. To be effective at using this approach, you have to be willing to pay attention to details. You have to, for instance, be careful about labeling your points here. You have to be careful about little stuff like the minus and -1. So this approach favors people who are really sort of tidy and neat in their approach to equations. I was not naturally that way in middle school. So for me, probably a better approach, and again, everyone's different, would have been something that's a bit more visual and conceptual like this. You could say, graph the points, -1, 2. Here we go. We start at the origin here. Here's the origin. We're going to go 1 left and 2 up. Okay. I'll label that. That's -1, 2, right there. And then we're going to graph the point 3, 5. Go 3 to the right, 1, 2, 3, 4, 5, up. Takes a little bit of time, but this is a really elegant and satisfying way to go. Let's take a look. We want to find this distance. Yeah? And what are we going to do? Well, we're going to drop a right triangle, just like we've done with some of the other problems in the past. We go, you could do it one of two ways, but I'm going to go down. I'm going to go like this to this point here and across. The horizontal distance here from -1 to 3 is 4. The vertical distance between 5 and 2 is 3. Yeah? And you'll notice, right, that these numbers show up in the other approach too. They ought to, because we're leading the same direction, that this 4 and this 4, same thing, horizontal distance. This 3 and this 3, same thing, vertical distance. Okay, so in any case, what you're going to do from here is you're going to write, I'll go to black, a squared plus b squared equals c squared, and you're going to say 4 squared plus 3 squared equals c squared, and this becomes, like we did in the other problem, 16 plus 9 equals c squared, and then we say c squared equals 25, kind of flipping that around, and c equals 5 units. Either way, ladies and gentlemen, whichever way you do it, the answer is going to be 5 units. And the reason that both approaches work is that both approaches are boiled down to different ways to express the Pythagorean theorem. That's the beauty of math. We can express things geometrically, like in approach 2, or algebraically, and it ends up meaning the same.